holes in between 45, so that's 4.5 each. So you have 1, 2, 3. So 3 times 4.5. 3 times 4.5. We are talking about the negative now. 3 times 4.5. That's 13. That's minus. So the roots of the equation and the roots will definitely be minus 13.5 or 82 degrees. So these are the roots of that equation. And if the question asks you to determine the maximum value of this, it has to determine the maximum value of this. So you have the maximum value of this is the point where the 2 sine theta plus 3 cos theta is at point M, where it is 45 degrees. So let's see it. Okay, yes, this is the minimum. Where the curve is going this way is the minimum. Then the maximum is the point. This is your minimum curve. This is your maximum. So this point, you trace this point to the horizontal. So this is the maximum point where the curve, where you have the curve. The curve is at maximum here and the curve is at minimum here. So at this point where it is maximum, you trace it to the corresponding horizontal axis and locate the angle at that point. So the angle at this point will then be this point. So the maximum value of, therefore, hence the maximum value of 2 sine theta plus 3 cos theta is equal to 45 degrees. And these are the respective solutions for example 1 and example 2. Coordinate geometry. Coordinate geometry, under this coordinate geometry, we're talking about some subtopics. We have Cartesian rectangular plane with points. We have distance between 2 points. We have the midpoint of a line segment. We have equation of a line, gradient and intercept of equation, and determination of the angle of the concept. So the first thing we have to talk about here is to talk about the Cartesian rectangular plane with points. So if you have to talk about Cartesian rectangular plane with points, we are going to consider a scenario like this, where you have your x and you have this as your y. Then this is your vertical axis and this is your horizontal axis. So if you have to consider a point, let's say 3, 1 here, and we have b, let's say we have 5, 3, for example. Then here, that means, let's say this is your 0 origin. Then we have, let's say this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Then we'll also repeat it here: 1, 2, 3, 4, 5. Then if you have to consider a point, let's say 3, 1, for example, this is the point. So this point where they intersect here, we call it A. The point is A, and that is 3, 1. Then 3, 5. Then we have a scenario like this, intersecting where they meet, like this. Where they meet here, we call it B, and that is our 5, 3. And this is an example of a rectangular Cartesian plane with points, where we have A, B as our respective points. Then now we have to talk about distance between 2 points. We have to talk about distance between 2 points. Let's say we have, under our coordinate geometry, we have our x as the first and it's y. This is the way you have it. We have the coordinate. So we are talking about 2 points, let's say A, 3, 1, for example, and we are talking about B, whereby we have 2, 4, for example. And these are the 2 points. These are the 2 points. So on our Cartesian plane, let's say we have a scenario like this, and we have your 5, you have your 4, we have our 3, we have our 2, we have our 1, and we have your 0 origin, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, like this, and so on and so forth. Then here we have 3, 1. But let's consider this first. So let's say we have a scenario like this. We call it x1, y1. Then we have another scenario, let's say like this. We call it x2, y2. So the distance we are considering is the distance from this point to this point. We are considering the distance from this point to this point. So we are considering the distance. The distance will definitely be this square. This square will definitely be x2 minus x1 all square plus y2 minus y1 all square. So here, where D is the distance between the points, distance between the 2 points, distance between the 2 points. So automatically this distance, the distance D, can now be written as square root of x2 minus x1 all square plus y2 minus y1 all square. Now, if the points that we have on the board these are the 2 points that are given to us in the question, if these 2 points are the 2 points that are given to us in the question, and we have to determine or to calculate or find the distance between these 2 points. Find distance between A and B. You have to look for the distance between A and B here. All we just need to do here is we know that our A is 3, 1. So that means this is our x1, this is our y1. Then our B and our B is 2, 4. These are x2 and these are y2. So if you have to look for this distance now, then we'll have a scenario whereby the distance D will now be equals to square root of x2 minus x1 all square plus y2 minus y1 all square. So here, the distance D will now be equals to, what is our x2 from the question? We have 2 minus x1, that is 3 square, plus y2, what's our y2? Our y2 is 4, y1 square. Then we know that there is a square root that is affecting these two, the content of the back of what we have inside the square root. So here we have our D to be equals to 3 minus 1, 2 minus 3, that's minus 1. So you have minus 1 square plus 4 minus 1, 3 square. So square root of this, then we'll have D to be equals to minus 1 square will give us 1, plus 3 square will give us 9. So we have square root of this, which will now give us square root of 10. So the distance between these 2 points, A and B, will be root 10. And that is how to determine the distance. The question can be reframed in diverse ways. It could be to calculate the distance between 2 points. It could be to calculate the shortest distance between 2 points. So once you are given any question that has to do with determining the shortest distance or distance between two points, this is a formula you have to apply. This is a formula to apply. And when you apply the formula, signify your coordinates and impute the parameters or the values that are given to you into the formula, your answer comes out naturally. Now we have to talk about the midpoints of a line segment. We have to talk about the midpoint of a line segment. If you have a diagram like this, considering a diagram like this, then let's say we have a scenario like this. Have a scenario like this. There is our P, X1, Y1 is our Q, X2, Y2. Now, if we want to look for midpoint of this, let's say this is the midpoint of this, and the corresponding midpoint of this. It's not going to be X minus X1. It's not going to be, so as it's approaching this side, you have X minus X1. So as you are moving like this, you have